the introduction to the circuit analysis. Now I am coming to the first topic or the 0th topic which is required to understand what circuit analysis is. I have a habit normally to learn any subject. I always say first understand the title. Once you define the title, then things will become easier. So if you call this subject as network analysis, let me talk about these two words, network and analysis. Similarly, if you are talking about circuit analysis, let me talk about circuit analysis common. So let us take the basic fundamental definitions. Because this being the basic subject and the first subject for the whole other subjects, therefore I need to define the words that I am using. The word, let me go for the first definition called network. It is an arrangement of two more elements connected together and need not be closed. What I mean is, they are connected together. They need not be closed. I'll give a small example. Network is a very general word people are using. When you talk about networking of electrical elements, we call it as electrical elements. When you talk about computer networks, that is also networks. So when you are connecting computers to a host, each user is connected. And user is not connected. That's why they are not closed. For any user who wants to connect with another user, they must go through the host. Therefore, electrical components is called a network, electrical network. Computers is called computer network. And even you see nowadays, the day-to-day life, we talk about networking with people. The people are there and we network them. So the word network has become a general word altogether in all these topics I am talking, whether it is in electrical networks or computer networks or people networking. Everybody is telling one word, we are connected. So anything that being connected is called network. Even nowadays companies are networking each other or one another. So this word called network is such a simple general word. I said one word, they need not be connected. Why they need not be connected? Because they are connected to the central point or a node, but they need not be connected to each other. That's why I gave a best example. This is a T network. I call it as a T because it is in the form of T. If you see alphabet T, it's like one line and second line. So this is upper part of the T, this is the lower part of the T. So this T network, if you remove this load, that is not connected. Only after connecting the load, it is connected. That's why the best example I have chosen to define the network is T. Now let me take you the second definition, which is as equally important as, that's called circuit. The word circuit, wherever you use, it's called simply, the word circuit means closed. That's why if the network contains at least one closed path, then it is called a circuit. So this is very important simple word. Even in computers also people are using this. They are calling packet switching, circuit switching. So wherever you use the word circuit of people means they are connected. So if everybody is linked to one another, we call circuit. If everybody is linked to one person through whom they are connected, that's called network. So this is how we are using. The best example I have taken is pi network. You see this? Pi. This is one, this two legs. So this is like a pi shape. And even without load and source, this is closed. Even if you remove this load and source, it is closed. So closed is called circuit, open is called network. But by connecting this load, network is becoming closed. That's why every network becomes a circuit with load and with what you call source. And hence, I have used this word, you can see this, but generally, network and circuit are used in a similar meaning. So from now onwards, if I call a network, if I call a circuit, please don't be confused, because every network will be connected a load, therefore it becomes a circuit. So therefore, we will be using these two words interchangeably with the same meaning. So first you know what is the real meaning and later feel free to use both interchangeably. That's why we are going to use these two words called network and circuit with the same meaning. As I said, the third word I am going to introduce to you is analysis. So network analysis, circuit analysis. The word analysis is not a great word. It's not a strange word. It's a day-to-day life everybody use. They use a analyze. Analyze a person, analyze the situation. Analyze means finally getting something output. So look at here. This is, for example, a network. Input is there, output is there. Input is known, network is known, but output is calculated. So out of these three, output is calculated is called analysis. Analysis is calculating the response for the assumed circuit with the given excitation. That means circuit, because so many students are asking me, sir, without how do you get a circuit? Then circuit is not really given, it is assumed. I'll put on a paper. If I'm getting output, I'll feel happy. If I'm not getting output, I'll change the circuit again. So it is not a real fixed circuit. That circuit will be finally manufactured or fabricated. But till then, we can do lots of analysis. Please remember, the latest word that people are using for this analysis is simulation. If you see the PSpice in tools, you talk about simulation. If you see even MATLAB, we call simulation. So simulation means another name for analysis, ultimately calculating the output. When you calculate output, you can, this is basically trial and error. That's why I use the word assumed circuit. If one circuit failed, go for another circuit. So that's like that, we go on giving, changing circuits and changing inputs finally to achieve output that we are expecting. Once you are, actually speaking, you are not supposed to change the input. In an industry, in a company, if the input is coming, it is coming from output of somebody else. And if you say change the input, he will say, how can I change? Because it is output of me. Suppose my output becomes somebody's input. Just example I am teaching now, my output is input for you. So my output, if you ask me to change, I can't change. That's why the best thing to change is network. Where unfortunately in colleges, people change inputs, but in company, input cannot be changed. Never imagine to touch the input, but the only thing you can change is go on change the network or the elements in the network till you get what you wanted. This is what people are doing. For example, when you make friendships, you will have a trial and error whether that fellow will be suitable to me. And then if your expected output is coming, you will continue with friendship. If your friendship, if you are not getting expected output, then you will change your friend. It can be boyfriend or girlfriend, doesn't matter. Analysis means you are going to do n number of times, because till you get output, you need to do it. That's what some people are calling in outside in India and some countries, people talk about dating, and they go on thinking and studying each other, and finally once they are happy, they'll go for marriage. Otherwise, analysis end of it. Analysis is such a thing, day-to-day life everybody is doing this. You can have a daydream, that is also analysis. And if you are dreaming something great that you know, suppose you think of becoming a prime minister, then if it's not working out, don't go for synthesis, but you can always analyze. That's why in engineering, the first phase of work is analysis. Once the output is coming, then only we go for this word called synthesis. So analysis you can do 1,000 times. That's only a paper work. That's only a computer work. But manufacturing is only once. Just like you analyze 10 people and marry one person. Once you marry, you can't change a person. So analysis talks about so many times you can try, but finally, whatever is being successful, and we go for manufacturing. Because once you manufacture, you can't throw it like a paper. Sometimes we spend crores of rupees on that. It's like a satellite you're manufacturing, and once if you don't analyze clearly, and the total satellite goes and hundreds of crores, you say get wasted. That's not possible. That's why an engineer is expected to do a lot of analysis. Analysis has to be thoroughly done. Actually speaking, you can go on changing the inputs differently. Even the atmosphere you can change. You can change the circumstances. They will be coming at higher level called control systems. You will study too much of analysis, how to really do it. But at this level, I am only introducing this one word to say, you go on changing the network till you get your expected output. Once you get the output, then go for manufacturing. That is called synthesis. So synthesis means realization of a circuit to achieve the expected output with the available input. That means in synthesis, our target is to get circuit. So getting a circuit is synthesis. Getting output is called analysis. So this is what my 3 words defined. So I have defined network, analysis, circuit, analysis. Let's go for the basic elements. Elements are basically what exactly the definition is. These the components used in this circuit are called circuit elements. Whatever components we use. What are the components? They can be voltage sources, they can be a resistor, they can be capacitor or inductor or diode, etc. One thing you remember carefully. These are the 3 elements we use more again and again. RLC. At times we use M. M means mutual inductance. So when you use mutual inductance, we call it as induction extension to the inductor. So therefore, though we talk about RLC, you can also add M. M means mutual inductance. But remember, if you want the details how they have come, that's called, if you want to study the material and the component, there is one subject called materials and components. This materials and components is a subject which is there in IES, but it's not there in GATE or PSU. There is only one exam where we use these materials and components, but that will only tell you one thing, how electrical components came and what is the material used for that. Or if you want to mathematically understand RLC components, you must go to EM theory. So the back end for this subject is EM theory, which gives mathematically the treatment of this. Or if you go to other subject called materials and components, that is going to be giving the values of components here. Therefore, we can study the components and we can mathematical study, understand those things. Those are the 2 things. So the prerequisite is not a prerequisite as such. If anybody is interested to know more about these components, you can go to EM theory and you can go for what you call materials and components. These are my suggestions to go for those 2 subjects, but otherwise we can take along without too much of difficulty. Then let's see classification of sources. How the source, actually meaning what is the source? Source is something which has energy within. It doesn't take, it only gives. So anything that gives is called a source. For example, voltage source, it gives voltage. So therefore, source definition is something has energy, has its own, it is have within. That's why sources are AC sources, DC sources. AC means alternating current, DC means direct current. And this AC source can be an ideal source or practical source. Actually speaking, ideal source is only for theoretically, but practical source is practical. Similarly, ideal source, practical. So ideal sources are not there physically. Even if they are there, they can't be used. That's normalized, gave a statement for most of the subjects in engineering. Then, so looking at these sources, let us see, as ideal is not possible, we are concentrating on practical sources. Practical sources are voltage source, current source. To be straight away, the current source does not exist physically. Why current source does not exist physically? For example, if you want to know how much current is, if you go to a plug, if you see a plug, any electrical plug, what is there in that electrical plug is not the current, it's a voltage. If you want to really see how much current is coming, whether current is there, you have to go and touch it. You go and put your hand in that plug, current will flow. If you want to see the current, you go and touch the plug. You will not be there to see because you are dead. So never attempt to see whether current source is there or not. Actually speaking, current source will not be there because it flows. Only when it is connected, it flows. That's why. So please understand directly right away from now, wherever current source is used in networks, it's only for analysis, not for real. That's why current source, whenever people use, it is only for analysis, and equivalent diagram for voltage source we draw, it doesn't exist physically. Actually, some students came to me, they said, "Sir, we have seen the current source." I asked them, "Where did you see?" They said, "We have seen in power supply." And there is one supply in colleges. Normally in every college lab we have 3 boxes. We call it as 3 dabbas there. In all the 3 boxes, one box is a power supply, other box is function generator, third box is CRO. And when I said, "Did you ever see a current source?" somebody said, "I have seen it." And he said, "Where do you see?" He saw in the voltage source. And he has seen the power supply. In power supply, it is true, there will be two things to see. You can see how much voltage is coming out. You can see how much current is coming out. And his understanding was that voltmeter he is seeing voltage source. And he is thinking that current meter or ammeter as a current source. The ammeter is connected there to understand if there is any overload. By mistake, any short circuit happens in our applications, there will be overload. When the overload comes, you know what happens? There will be high current. I mean, when the short circuit occurs, there will be high current. When the high current comes, that ammeter will jump to highest one, that is to give you precaution. That's why, please understand, what you are seeing on the power supply is not the current source, is only ammeter. It's a measuring instrument, not the source. And don't confuse with the measuring instrument and source. Source is giving, measuring instrument is taking. Source is supplying, measuring instrument is measuring. Therefore, current source never exists. It cannot exist under any circumstance. Voltage source exists. But for analysis, as I said, this network analysis, subject is analysis. You can assume certain things which are not physically existing. But when you go to synthesis subject, you can't do so. In synthesis subject, what happens is, you cannot assume something which is not physically there. Because synthesis means physically should be there. So therefore, let us assume circuits in that voltage source, current source. And voltage source can be a dependent source, can be independent source. And when you talk about independent source, to be very strict, it is not a source. For example, you take a moon. Moon is depending on sun. Sun is independent. Moon is dependent. Suppose sun has become dark, moon automatically become dark. So if independent source is 0, dependent source automatically becomes 0. That's how you need to understand. Therefore, don't never say about what you call dependent source as a source. It's not a source. The very reason it is depending, it's not a source. By the definition, as I said, source means energy within. So dependent source is depending. That's why it is not a source. So if you see this total table I have given here, only independent voltage source is the source. Dependent voltage source is not a source. Independent current source is not a source. Dependent current source also not a source. Among all these 4 things I have been talking on this diagram, all others are for analysis, but independent voltage source is the only voltage source. Okay. Now, it is depending on what? If it is being controlled by voltage, we call voltage control voltage source. If it is controlled by current, we call current control voltage source. So voltage control voltage source, current. It's altogether basically voltage source. Why it is voltage source? Because it comes under voltage source. See this flow diagram, you will understand. Similarly, if you see the current sources, you will understand. It's a voltage control current source, current control, this is current source. So current sources are 2 types, voltage sources are 2 types. Then, these are the meanings I have written here. and you can follow. Then let me take you to ideal versus practical sources. As I said, ideal sources are not possible, but still we will imagine that. First come to practical voltage source. A voltage source will have internal resistance. Every voltage source will have some internal resistance. When you have an internal resistance, that is not really we have connected it, it is inherently available in a voltage source. So it is a source which is internal and load is connected. The voltage across this, how much it is? You can see here, observe please. I have given an equation here. VL is equal to Vs minus I into R. So what is going to happen here? If IL is removed, how much voltage come? That is VL is equal to Vs minus I. So as I is increasing, automatically VL is decreasing. Look at here. If I is increasing, drop is increasing. You can't change R here because R is not you connected it or somebody connected it. It is the equivalent internal resistance. And if this internal resistance is 0, that is called ideal source. So if it is not 0, there is some drop within. Just like this. Some students will be there. They have a lot of concept. When you ask them to speak, they'll have internal problem. They'll all have a doubt saying whether what I am saying is maybe wrong, and they may say that. And that's why they can't communicate at all. Too much of knowledge without confidence is called internal resistance. Internally, they get a lot of negative feedback to themselves and saying you may be wrong, you may be wrong. That is what actually we call it as internal resistance is dropping his efficiency. If you want the best source, if you want to send the maximum value to the output, what is the best thing? Very simple thought, anybody can say, if this total voltage to appear here, this resistance should be 0. Even a layman can understand that. If I have to speak what all I have, I should not have any internal resistance. And this internal resistance is always a doubt in the subject. If you have a doubt in the subject, automatically you will go to negative marking in the exam, and be careful, check your internal impedances. So coming to this circuit also the same. There is an internal impedance, and as I is increasing, VL is decreasing. That's why the graph is coming. This is called practical voltage source. As I said, if R is 0, you can check here. If R is 0, VL is equal to Vs. You see, R is equal to 0. That's why VL. So I have a new definition for ideal voltage source. You can also try with me. Ideal voltage source is the one where load voltage is independent of load current. The point is, if this is 0, if R is 0, whatever variations you bring here, whatever is here will appear here because these two are parallel. Parallel voltages are always same. So remember, the definition of ideal voltage source is for any changes in the load, for any changes in the load value or load current, what happens is voltage will appear here. That's possible only when you say R is equal to 0. So therefore, ideal voltage source is the one where VL, load voltage, is independent of load current. What a beautiful idea. That's a simple way to talk about ideal versus practical source. Let me take you to current sources. As already said, current source does not exist, but for analysis sake, we need to talk about it. And when you see here, current source, there is a resistor. Please understand here, why this resistor is here. Why our elders have brought this resistor in parallel? Very simple. Current source flows. For current to flow, there should be closed loop. If the closed loop is not there, current cannot exist. That's why our elders told us that this should be in parallel. Go back to voltage source. Even if you remove this is no current, the total comes there. Voltage source can exist under an open circuit condition, but current source cannot exist in a open circuit condition. That's why we always put in parallel. Therefore, what is the current in the load? Current in the load is Is minus V by R. Now please look at this. If this VL changes, automatically IL changes. And look at this diagram, this is what happening. So as VL is increasing, or as the voltage is increasing, current is decreasing. And whereas here, if this resistor is open circuit, open means what? Infinity. If this is open circuit, automatically total current comes there. That's why you put a load here. Enjoy this diagram. If this is open circuited, that means infinity. Infinite impedance means no current flows. Whereas as no current flows here, automatically total current comes here. That means it is parallel. Therefore, now what's the definition? Ideal current source is a source where current is constant irrespective of the load voltage. Now very simply to say, if the load voltage changes, there is no effect if this is removed. That's why it is called ideal voltage source, current source. So these are the talking about sources. Now I am taking you for dependent source. Let's go to dependent sources. The word dependent, so many times I used to have a doubt as a student, and also so many students are asking me, sir, why this symbol has come? What is the symbol for dependent source? I gave a funny example. I think it is mostly right. You look at this, we call dependent source symbol as a rhombus. You know why it is called rhombus? Or why exactly the symbol came? Very simple. Look at here. This line goes how long? Till another line comes. Therefore, this line is going depending on second line. Suppose if second line doesn't come, it goes continuous. That's why this line depending on this line. Therefore, rhombus is the best way to represent dependent source. And that's how the word came. Every dependent source from now, whether it is electrical circuits or electronic circuits or any subject like machines or power system, whatever you call, everywhere there is a dependent source. As I already told you, if you draw equivalent circuit of a transistor, you will have a dependent source. If you draw equivalent circuit of a transformer, you will have a dependent source. Therefore, every bigger elements and every systems are going to have dependent source. It is depending. That's why please understand the reason for taking this symbol. By mistake, some people are keeping the symbol as a circle. Even for dependent sources, that is somewhat misleading, but I am not going to do it. We will definitely take dependent source means rhombus and independent means a circle, because in an independent source means in a circle every point is independent. Take a center point, just the radius, the point comes. That's why rhombus is meant for dependent and circle is meant for independent. This is the notation, please. We will follow it. Let's go for voltage control voltage source. What exactly this means? This is depending on some other thing. It's a voltage source because plus minus. This is current source. This is voltage control voltage source. This is current control voltage source. This is depending on, for example, K into V. Depending on voltage. This is depending on current but develops voltage. So, secondly, you can see current sources. You look at this arrow meant for current. So this is depending on voltage, this can depend on current. So there are altogether 4 sources as I've been discussing from beginning. Now let me take you to some other elements. That's called bilateral element, unilateral element. Very simple thought. No need to confuse. Unilateral by simple English to say one way. And most of the electrical elements are bilateral because current can flow in both the directions. For example, you take a resistor, current can flow in the both resistors. Inductor and capacitor also same. Such elements are called bilateral. And if you see what you call electronic elements or devices we call, they only take the conduction in one direction. For example, diode, one direction. That's why the arrow is one direction. Transistor. So almost all active devices are unilateral and passive devices are To be very simple, electrical components we call passive and bilateral. Electronics components we call active and unilateral. I told my lectures in the previous introduction lectures, passive means it can take any amount of energy. Active means they demand minimum amount of energy for excitation. That one we call it as cut-in voltage. So these are the two definitions. Then coming to lumped and distributive elements. Look at this. Very simply speaking, the word lumped element means an element that can be isolated from the circuit. If you can completely remove it and put it aside. But distributed element means you cannot remove it. For example, lumped element resistor is there, distributed element resistor is there. For example, lumped element resistor means ohms, 10 ohms let us say. Distributed element means 10 ohms per meter. The best example is RLC circuit here. See here, second point. And another distributed element means transmission line. If you draw the equivalent for a transmission line, you will have RLC. But the only difference between the lumped and distributive is one is distributed along. You can't separate it. That's why distribution. So remember these things when you talk about circuit theory. Then linear and non-linear. Linear means very simple definition. An element is called linear element if and only if the value of the element remains constant with varying current through the element. Very simple. I'll give you an example. Take for example 10 ohm resistor. Send 1 ampere. It is 10 ohms only. Send 2 amperes in the same resistor. 10 ohms only. By changing current, the value of the element should not change. Then what else change? By changing current, if the value of element doesn't change, therefore the voltage change. That's actually Ohm's law. Therefore, linear element, the value doesn't change. Whereas non-linear element, if the value of the element is constant with the varying current through the element, we call linear elements. So non-linear elements are diodes and transistors. Linear elements are RLC. But remember one thing, when you talk about diode and transistor, particularly transistor, it is basically non-linear, but in active region it works like a linear. Similarly, operation amplifier is basically non-linear, but it can be treated as linear. That's why I said one word, all electrical elements are linear by nature, but electronic devices are non-linear, can be put into the condition of linearity also. That's called amplifier. So this is the meaning of linear and non-linear elements. Then coming to passive and active. As already said, the elements, active elements I am defining. The elements which are activated with specific amount of supply given by the source is called active. They need specific amount. If you give for example a diode 0.1 volt, it doesn't work. It says I need 0.6, 0.7 for silicon. Similarly, passive means it can work with any. It's so passive. They don't give energy, they take energy, but they can respond to any amount of energy that you really supply. Now I am going to come to the lastly 3 words I am going to introduce and then finish this talk. The first thing is talking about from where the resistor came. That is Ohm's law. Let me define the Ohm's law. For linear time invariant system, the voltage across the uniform conductor is directly proportional to the current through the element at constant temperature. Please remember 3 words I have made very interestingly. For example, Ohm's law applicable for both lumped distributive elements, but linear condition must be satisfied. The word linearity is must. I'll give an example. V is proportional to I. V is proportional to I and the proportionality constant is R. Suppose you look at this, V is equal to Ri. Some people call IR. I don't like it. some people are, most of the books are writing about V is equal to IR. There's a lot of difference. For example, in high school mathematics, if you say y is equal to mx, m is slope. If you say y is equal to xm, x is slope. So we need to be very careful what is slope, what is constant. So the constant is always slope. That's why the best thing is to say V is equal to Ri, not IR. At later stage, we may take it as a very easy way. But at this time that I'm introducing, I need to be very serious. You need to be serious to learn it is Ri, not IR. If you say IR, I is constant. If you say I is constant, it is a transistor. If you say R is constant, it is a resistor. There's a big difference between these two words. You can see in EDC, not now, but as on today, V is equal to Ri. So please understand here, three words I have used. One is linear time invariant. See, it's called linear because it is proportional. Second, time invariant because I may have dependence on T, but R will never have dependence on T. For example, if I say V is equal to Ri, it is DC. If I say V is equal to R into I of T means it is changing on time. And whenever there is a change in time, there is a change in time in I and V, but not in R. R is fixed. It is not changing with time. It's not changing with amount of current. It's not changing with any temperature. These three words you need to be very clear. Everybody only talk about temperature, but you must understand by temperature it is fixed. So R has to be fixed, including uniform conductor. I said uniform conductor because it should be uniform at every point. Otherwise, there will be some distributions developed. The Ohm's law may also fail. So conductor should be uniform and it should be linear. It should be time invariant, and finally temperature is constant. That means such an element is called resistor. And but sometimes there is people are thinking that Ohm's law is meant for resistor. No, Ohm's law is meant for conductor. Resistance is not an element. It is the property of the conductor. So resistance is the property of a conductor. Therefore, it is defined for conductor. So Ohm's law is applicable for both lumped and distributed elements, but linear condition must be maintained. For example, as I said, if you go to transmission line, which is called distribution, you can still apply the Ohm's law there. But the only difference is it must be linear. So this is about Ohm's law. Then electrically, how are the equations? V is equal to Ri, therefore R is V by I. This is called physical. As I told you at the beginning, for each component you can understand physical relationship. That's called rho L by A. In other words, to say, this is A is a area. If you change the length, R changes. So far we said R is fixed, but now R can change if you change any one of these three. So the best thing is, I always challenge people to say, try with the resistor that you have whether you're getting current. If you're not getting the required voltage or current, change the resistor itself. Changing resistor is by three means. First, change the length. Second, change area. Third, change the resistivity. Please remember, you have four ways to get voltage. First thing is fixed R. Second is L. Third is area. Even if all this fail, next one throw this material, get another material. That's called rho. So changing the material. That's why material makes the component. Component makes the voltage. So all this material resistivity can be brought into this. The best example is strain gauge. For example, strain means force. You put a force there, length will change, automatically R will change. So unit for this is ohms, and this is the equation for power, and this is about resistor. This is a very simple thing. When they are connected in series, where there must be added. If they are in parallel, you must be taking 1 by. So this is series and parallel combination of resistors. That's not a big thing for you. You can just study there. Now let me talk to this second element called capacitor, the greatest element. And somebody said this is a capacitor because it has capacity to store energy. And that was the first element the people started storing energy. Like you are keeping your money in the bank, you can store electricity in the capacitor. What a great thing. Now we are able to store energy just like storing money in the bank. So you can store it and use it later. What a powerful idea that came through the capacitors. This is basically developed by Faraday, Michael Faraday. He has developed it with the principle of electrostatic. So electrostatic gave this concept. For example, you have one plate, another plate. There is a charge here, the total charge is developed there, and in between there is no connection. That's why capacitor means there is one idea. Please remember this great idea. Physically disconnected, physically isolated, but electrically connected. You need to remember this word. Electrically they are connected because this total charge is going there. Physically there is no connection because between these two plates you have insulator. Insulator means disconnected. The greatest funny thing that nobody really concentrate is inside the capacitor no current, but when you put the capacitor in the circuit, current flows. That's very interesting. In the capacitor no current, but in the circuit it flows. That's why William Height has brought a new word to say it's not a closed loop, it's a closed path. It's when that is connected you get it. So current is flowing in the circuit without flowing current through it. What a powerful idea. That is what called capacitor through the flux. So what is connecting between these two plates is called flux. Please understand, flux is a general word everywhere. Even you talk about soldering. When you are soldering, you will put a lead there, and if it is not making a connection, you will always put flux there. The flux will make a connection between circuit and the element there. So wherever, even if you human beings also, you can use that word flux. Therefore, flux is connecting them. Though there is no physical connection, it is making the connection. That's why storing, this is the element. What is the electrical equivalent? Electrical equivalent, you can see what is the equation involved. So when you look at this, this is the charge. As I said, you can store half CV square. Half CV square, you can always talk about this epsilon. So look at the capacitor and how this is the physical relation we have. Now let us go to inductor. Actually, inductor is also told by the same Michael Faraday, but it is another principle of magnetic flux. That was electric flux, this is magnetic flux. I'll tell you very simply to understand. The best way to understand inductor is take a transformer. You have a secondary coil, primary coil. Primary coil to secondary coil, they are nowhere connected, but flux is connecting them. That's why when you come to inductor, there is a word electrically isolated but magnetically connected. So who is connecting or inducing all this? Magnetically. That's why you have E is proportional to d phi by dt. This is called Faraday's law. On this simple equation, your electrical students know, on this principle the generator is developed, and every time the flux is depending on I. Therefore, in the place of flux we can put I. Therefore, E is di by dt, E is LDI by dt. And this is the physical explanation I gave. As I have promised you, you need to know, or I need to tell everywhere physical explanation. Physically, all the three elements have effect. You can change them. So if inductors are connected in series, inductors are connected in parallel, one thing you can always understand, resistor and inductor is same, capacitor is opposite. And this is where we have, today we will stop it here, and then we'll continue problems in the next lecture. Till then, you go through the lecture and then study, then you will be able to understand, and we will give you previous papers and all that, how they are asking. You will understand. One thing I always give a challenge, in whatever the concepts we have dealt, how best they are able to solve the questions. Then you will get a confidence. So all the theory that I am developing or the concept I am developing is to really give you confidence of solving problems. Therefore, I'll be solving with you, then you will get a confidence along. Till then, bye.